Hey guys, after you have taken your practice test or your practice quiz, you can go ahead and follow along with these solutions here. I'm going to go through them and show you some visuals from our review slides, some pictures to be able to hopefully explain what's going on with each problem. So let's go ahead and get started. Number one, school administrators collect data on students attending school. Which of the following variables is quantitative? So remember, quantitative data is going to be typically numbers. It's going to have some sort of units associated with it. So if we're classifying them by their class, freshman, sophomore, junior, and senior, that's going to be categorical because we're sorting them into buckets, 1, 2, 3, and 4. Grade point average, the units are going to be GPA, so up to 4.0 or whatever they use for their GPA, but that is going to have a units to it and it's going to be a number, so that is going to be quantitative. But let's go ahead and look at the other ones real quick. Whether or not the student chooses honors classes, it's going to be yes or no. It's clearly categorical. It's going to sort them into two buckets. Whether the student has taken the ACT, again, yes or no, sorting them into two buckets or categories. So our answer for this one would be B as in Bravo. Number two, the SPCA collects the following data about dogs that they house. Which one is categorical? So it would be breed. So breed is going to break them down into categories by whatever the breed was. The breed's not quantitative. You can't go from a scale from, I guess, like small breeds to large breeds or something like that. That doesn't even make sense. Or alphabetical. That doesn't make sense either. So it's going to be categorical. We're sorting them into buckets depending on what their breed is. Their age is clearly going to be quantitative because it's going to be a range of values, quantitative values with years old being the units from newborn all the way to 18 or however old the oldest dog is. The weight is going to be in pounds. Again, clearly quantitative. Going to be a value from the lightest one to the heaviest one. Number of days housed, so that's going to be anywhere from 0 all the way to the longest one, and the units are days housed. So clearly this one would be breed. On September 5th of 2014, Clinical Pediatrics published the article Fast Food Consumption and Academic Growth in Late Childhood. So they're looking at childhood here. The researchers found evidence that high levels of fast food consumption were associated with a slower growth of academic skills. Interesting. What is the population of interest? So remember, we have our population, and our sample is going to be a subset of the people that we actually used in our experiment, or which I think that's what this is. No, this is an observational study. Because they didn't assign people fast food consumption. So it's just an observational study. So we can't actually prove a causal relationship with this. So it's just an association between the two. There could be lurking variables and other things going on. So anyway, so the 8,544 fifth grade students that they studied, that would be our sample, not the population. Okay, so the overall population is all children in the U.S. or wherever we're looking at. So that's going to be D. The fast food restaurants and number of fast food meals consumed per week, that's going to be information that they actually gather. It's going to be one of the variables, but that's not the and part of the fast food restaurants might be part of the variables if they sort it out that way, but more than likely that would be some of the variables that they're gathering, but that's not the actual population of interest. That would be one of the questions that they would ask one of those fifth graders apparently. Our table at the right shows whether students in introductory statistics class like cats or dogs. This is actually, that would be kind of fun for us to do, the contingency table to see how many guys like dogs or cats or both or whatever, or neither. So what percent of students in the class, so of all the students in the class, like both cats and dogs? So both cats and dogs is going to be yes and yes, which is 194 out of the total number of students in the class, 355, which is approximately 38%. What percent of students who like cats also like dogs? So only looking at the ones who like cats, what percent of cat lovers are also dog lovers? So do you like cats? Yes. So all the cat like people together is going to be 215. So of those, what percent like dogs as well? So 194 out of 215. Notice we have a different denominator here, which is going to be about 90%. So number 6, this is kind of a hard question, not gonna lie. What are the students' feelings about cats independent of their feelings about dogs? Remember, like with the Titanic question, we would look at the overall survival rate and we would look at the survival rate of one of the classes. And if they were all the same or very close, then we could say that there was weak or no evidence of an association. So therefore they were independent, or we believe that they were independent based on our sample. So in this case, if we look at the part B, says yes, says 64% of the class likes cats. So for the cat liking, that's gonna be okay. So do they like cats? So 215 out of 335 is 64%. So that's the overall rate for liking cats. And if we look for the people who like dogs, which is this column right here, 194 out of 304 is also close to 64. It's like 63.8 or something like that. So because those two are really, really close, then we can say that they're independent. So you liking dogs does not raise or lower your chances, your overall chances of liking cats. So they would be independent. You can go through the other three, but they're going to be false if you want to go through them. All right, which of the is true about the data shown in the histogram? So over here, the data, is it skewed to the right? No, it's skewed to the left. Remember, we always follow the tail whenever we're describing skewed data. So that would be skewed to the left. So we can cross that one out if we want. We know it's not that one. The mean is probably smaller than the median. Remember, the mean is going to be drawn towards the tail by these kind of outliers and extreme values. So our 50 percentile is not going to be bothered by it being skewed. So the median is probably going to be larger than the mean, which is going to be smaller because it's skewed towards the tail. So that would be true. We would use the median and IQR. That is true. We can't use mean and standard deviation because it's not unimodal. Well, it is unimodal, but it's not symmetric because it's skewed. Okay, so we have to use the median and IQR. So our answer would be B as in Bravo. Number 8, stats teacher tells you your test score was in the 3rd quartile for the class. What is true? So remember, our quartiles are breaking them down into chunks of 25%. So if you scored in the 3rd quartile, that means you're 75th percentile, which means you scored better than 75% of people, but not as good as 25% of the people. That's what that means. So does not mean that you got a 75% on the test. That would change for every test, right? It means you scored 75% better than everyone else. Or you scored better than 75% of other people in the class. You can't really tell without standard deviation. No, that's not true. 25% of your classmates got a score that was higher than yours. That's what that means. So the answer is D, 3 only. We might choose to display data with a stem plot rather than a box plot because a stem plot blank. So stem plot is just another word for stem and leaf plot, just like a box plot is the same thing as a box and whisker plot. Histogram is just a histogram, by the way. So the difference between a box plot and a stem and leaf plot, we might choose to display with the stem and leaf instead of the box plot. So why is this one better than the stem and the box plot? Well, the box plot is just a summary of the data. It doesn't really show us the actual shape of the distribution. Also, we don't see the actual data points themselves. And that's also a benefit of stem and leaf plot over a histogram, even though they show the same general shape of the data. That the histogram doesn't show the actual data itself, but a stem and leaf plot will. So reveals the shape of the distribution. Yes, that's true. Now a box plot will tell us if it's generally skewed, like this one has a right whisker longer than the left whisker. The median is closer to the left first quartile, and there's an outlier on the right side. So clearly we can see that it's skewed, but we can't see the actual like modes going on, or if it's multimodal or anything else. That you'd have to see the actual shape of the distribution from the histogram or a stem and leaf plot or a dot plot, or dot plot's what we call it. Anyway, so the reason why we would use, yes, stem and leaf plots will show us the actual shape of the distribution, unlike a box plot, which is just a quick summary. It is better for large data sets. That's actually backwards. We would prefer the box plot and the histogram for larger sets of data. And if we had a smaller set of data, then we could actually look at the stem and leaf plot. So that one is not true. I'm going to cross that one out. It displays the actual data. That is true. With stem and leaf plot, that's the only one that shows the actual data. So we only use it for smaller sets of data, like up to 45. Anything bigger than that, we're going to use a histogram. And if we're comparing multiple ones together, then we'll use a 5-number summary from the box plot, modified box plot. So our answer is going to be 1 and 3, which would be C in this case. Number 10, professors kept records on grades of students who earned in his class. If you want to examine the percentage of the students earning grades A, B, C, D, and F during the most recent term, what kind of plot would he make? So if he's graphing out percentages, that's done with a pie chart. Also grades A, B, C, D, and F, those are categorical, right? A, B, C, D, and F. We're not going to graph this out on quantitative data like a histogram because we don't have all the actual percentages like a 92%, 93, 94. All those 90 percentiles or percentages are going to be grouped into one category. So in this case, we're talking about categorical data. We only display categorical data with a segmented bar chart or a pie chart. So in this case, the only one that makes sense for categorical data is a pie chart. Box plots, just like we saw in the last one here, that's done again with histograms with quantitative data. Time plots, that wouldn't even make sense. It's a scatter plot where the The x-axis is time, but it doesn't even make sense because they all get the same grade at the same time. I guess if you plotted one person's grade as they went throughout the year, that would be a time plot, but that's not what we're doing. Dot plot is going to be very similar to a stem and leaf plot, except it's going to have X's or dots on it. Again, that's done with quantitative data, not categorical. So pie chart's the only one that makes sense on this one. The SPCA is kept careful records of the past 20 years. They want to show the trend in the number of dogs they've housed over time. So that's not what this is, but this is a time plot, by the way. So as time goes on, the number of dogs that they house would be a time plot. We wouldn't use a box plot because, again, we're showing how it changes over time, and so it's got to be a time plot. The others don't make any sense either. Veterinary bills. So here we have an OGI. We want to estimate the IQR. So we got to find the first quartile, 25%, and the third quartile, 75%. So I just drew the lines over here, drew the lines going down, drew this line going down. So it's going to be from about 75 to 175, which I can like visually check it out. It's 100, from 100 to 200. Yeah, kind of cool. I know you wish you could do that. But anyway, so our IQR is going to be about 100, which is C. Which is true about the weights of people shown in the parallel box plot. So we have two groups here. The left is going to be a smaller weight. The right side is going to be a larger weight. Just in general, that's how we roll. So each person in group 2, so group 2, is heavier than the lighter half of group 1. So the lighter half of group 1 is going to be this median. Okay, so that's the lighter half of group 1, and everyone, even the minimum, is going to be heavier in group 2 than the lighter half of group 1. So that one is true. You can look through all the rest of the other ones, and they're not going to be true. I guess we'll do that real quick. The third quartile of group 1, so group 1, third quartile right here, is less than the median. It's actually a little bit heavier than the median of group 2, so that's false. The interquartile root of group 1, so that's going to be the box of group 1, is less than the median. Okay, so the entire box is less than the median of group 2. That's not true either. Person weighs in group 2 or skewed to the left. All right, so looking at group 2, this is kind of interesting. When we're looking at skewedness, there's two ways to do it. You can look at the box, and you also look at the whiskers. So if we look at the whiskers, it looks like it's skewed to the right because the right whisker is longer than the left whisker. But if we look inside the box, the median is closer to the right side than it is the left. So those two are kind of like contradicting or canceling each other out. So we wouldn't necessarily even say this was skewed. It's just kind of all over the place. But if we look at this one, looks like it's probably more likely to be skewed to the right because it's such the difference between the median and the first and third quartile. That one would be kind of skewed to the right, but neither of them are really skewed to the left. All right, so number 14, you're going to have two problems where they're not multiple choice. So on this one, we need to graph out the number of hours that these 16 random students were taking in the stats class. So the histogram is going to already be given to you. So not the histogram, sorry, the table or the scale and the chart or whatever is going to be given to you, so you don't have to like break that down. You just have to fill it in. So in this case, if we're going from 10 to 12, but not including 12 because 12 actually is in the next category, there's two of them, so you just shade in two. There's 1, 12, so 12 to 14, but not including 14. From 14 and 15, that's going to be 5 of them, etc. You can fill it in. Another way you can do this, if you guys have your calculators, because I know you do, it's kind of fun, is we can put the data in our list. So we're going to go to Stat and Edit, and I'm going to put them all into list 1. And then the next thing I want to do is graph it out. So I'm going to go second y equals, which is our stat plot menu. Make sure you only have one of them turned on. And then we're going to arrow over to our histogram, which is our third option. For our list, we're going to do list 1. So that's a little L1 that's above the 1. So we're going to do second 1. And then hit enter and enter again. Oh, no, we don't even need to do that. But we want to zoom stat. So we're going to hit zoom and 9 for zoom stat, and it'll graph it out. But if we notice it's not the same thing because our window's messed up. So go into window, and we want to do the window that matches our graph. So if we look over here on our graph, we have 10 to 24. So my X minimum is 10, X maximum, I'm going to put it at 24. And the X scale, I'm going by 2s, which kind of makes sense. Then you just have to hit graph again, and you'll notice that's exactly the same as that. I wonder if I could like click and drag. That's cool. Anyway, so you can do that to match the bin size and then all that other good stuff. And another thing you could do is you can hit trace, and it'll tell you for each category from bin size to 10 to 12. We had 2 which is a sample size is 2 or whatever. There was 5, and then we had 2, and then 1 again, then 4, and then 1. All right, so no big deal. Next question, they are asking Find the mean and standard deviation. That comes from the one variable stat. So we're going to go to stat, arrow to the right to the calculating tab, and one variable stats. We're going to do list one. So hit second and one again. And then frequency list, I think we can leave that blank. And then just hit calculate. Yep, that'll work. The x bar is going to be our mean, and the s of x is a standard deviation of x, which is 3.7. So our mean is 16.3, and that's our average, right? Our mean, and our standard deviation is 3.7 for our sample. Find the median and IQR. Well, we're going to get that from arrowing to the bottom. There's our 5-number summary. Our median is 16. The IQR is going to be Q3 minus Q1, which is going to be 5.5. Is it more appropriate to use mean and standard deviation or the median and IQR? Well, if we're looking at this, is it unimodal or bimodal or multimodal? Well, it looks like we have a clear mode here and another one over here. So it's really bimodal. And so since it's not unimodal and symmetric, we can't really use mean and standard deviation. So instead, we're going to have to use the median and interquartile range. All right, number 15. Box plots show the age of people involved in accidents according to their role in accident. So in the accident was a person, a cyclist, driver, a passenger, or a pedestrian. Passenger would be in a car. All right, which role involved the youngest person? So looking at the minimums, the youngest person was a passenger, and that age was an infant, so about 0 years old. Which role had the lowest median age? So the median is going to be the line in the center of the box plot, right? So the smallest one, these are really close, but it looks like the pedestrian one is slightly smaller, and that's going to be an age of about 21. Which role had the smallest range of ages? So not the interquartile range, that would be the size of the box plot. The smallest interquartile range would be the passengers, but the overall range is going to be from the minimum to the maximum, including the outliers as well, not just the whiskers. So the ones that had the smallest range would be the cyclist. And what that range is, it looks like from about 11 to 52, so a difference of about 31. They're saying that's about 54. And that's 10, so a difference of 34 or 40 years. Okay, anyway, it's kind of hard to read, but that's definitely more than 40 years. Whatever. I would say more like 42. Whatever. All right, which role had the largest interquartile range? So looking at the box plots, or the box itself, the biggest box we see is going to be the pedestrians, and that's going from about 20 to 64, so that's 44 would be the interquartile range. Which role generally involved the oldest people? So when we're talking about a general behavior, you're going to look at the box, the actual box itself. So which box is the highest? Well, these two are clearly the higher boxes. So then how do we break it down from driver to pedestrian? So we're going to look at the median. And so the median for the pedestrian is higher than the median for the driver. So if we think about it this way, the 50 percentile, half of the pedestrians were older than the younger half of the drivers. So we would go with the pedestrians here, even though they don't have the highest values, which were outliers for the other groups. So the oldest people were not pedestrians, but in general, pedestrians tended to be the oldest people. All right, so that's it. Less than 20 minutes on the solutions there for the quiz. So we're gonna do a review tomorrow. Maybe I should post the review. Maybe that would be good to do that tomorrow. I'll take a look at that. But anyway, we're going to do a review tomorrow, and then we're going to take the quiz itself on Wednesday. So another thing, keep in mind, we're going to finish the unit on the 30th. So if you have any homework assignments for these 5 chapters, we need to make sure all of those are done by the 30th. So if you've gotten behind, it means you're going to have to get even more than one day assignment done each day in order to catch up, because that's how math works. It's like my 3-year-old nephew told me one day that he's going to be older than me, and then I try to explain to him that's not how math works. So anyway, you are going to have to do more in order to be caught up, but after the 30th of September, I'm not going to take any more homework from the first unit, as we're going to move on to the second unit. So still under 20 minutes. Thank you guys for watching. If you have any questions, remember you can join our live office hours from 1 o'clock to 2 o'clock on Google Meets. And get all of your questions answered. That's why I'm here. I want to help you guys out. I know some of you guys are doing really well learning from these videos, and some of you guys really are struggling. So I would recommend, if you are struggling from the videos, you still need to watch them, but you can also join me during the live office hours, and the textbooks are a really good resource as well. It's actually readable, believe it or not. And the answers are in the back of the book for the odd questions, so you can look those up as well to help guide you through how to do the problems. And in general, I like to do the even numbers from your homework in the lessons. That way you actually have access to all the solutions. So there's no reason why you shouldn't be able to do well in this class. So I'll see you guys later. Have a good day.